Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area of a circle practice questions. If you want the video tutorial on area of a circle, go to corbettmaths.com/contents and scroll down to either videos 40 or 59. Alternatively, you could just scan this QR code on the front of the booklet. Anyway, let's start going through the video solutions to the practice questions. Question number 1. Okay, let's have a look at question number 1. So question number 1 says, shown as a circle with radius 5 centimeters. So we've got the circle and it's got a radius halfway across the circle is 5 centimeters. And we've been asked to work out the area of the circle. And we've been asked to state the units of our answer and to give our answer to 2 decimal places. So the area of a circle is given by the formula area equals pi r squared. And what that means is pi times the radius, which is 5 squared. So if we do pi times 5 squared, we will find the area of the circle. So we'll get our calculator and we'll press the pi button, so shift pi, and then times by 5 squared, and press equals, and then that gives an answer of 25 pi. But in this question, we've been asked to give our answer to 2 decimal places, so let's change that into a decimal number. That's going to be 78.5398 and so on centimeters squared. We've been asked to give the answer to 2 decimal places, so we're going to have an answer of 78.5. Now we've got 3 nines, that means we're going to round up, so 78.54 centimeters squared. And that's it. So the area of the circle is 78.54 centimeters squared. Okay, let's have a look at our next question. So let's have a look at question number 2. So question 2 says, a circle has a radius of 3 centimeters. So if we've got a circle, the distance from the center of the circle to the edge of the circle, or a point on the circumference of a circle, is 3 centimeters. In other words, halfway across the circle is 3 centimeters. And we've been asked to work out the area of the circle and to give our answer in terms of pi. So the area of a circle is given by the formula pi r squared, or pi times the radius, which is 3 squared. Now, we're going to be working this out without a calculator. Now, remember with Bob maths, we've got to do any squaring before we do the multiplication. So we have to do 3 squared. So 3 times 3 is 9. So we've got pi times 9. And then we're going to put those together and we're going to put the number 9 at the front. So the answer will be 9 pi centimeters squared. And that's it. So that's the area of the circle, 9 pi centimeters squared. And that's it. So the area of the circle is 9 pi centimeters squared. Okay, question number 3. So question number 3, this time we've been given a circle, but we've been given the diameter this time. So that's the distance the whole way across the circle through the center. And the diameter of the circle is 18 centimeters. We've been asked to work out the area of the circle. So the area of the circle is given by the formula area equals pi r squared. So it's going to be pi times the radius. Now halfway across the circle will be 9 centimeters. So we're going to do pi times 9 squared. And then we're just, because it's a calculator question, we can type that in our calculator. So shift pi times 9 squared equals, and that gives an answer of 81 pi, or 254.46900049 and so on centimeters squared. Now we've been asked to give our answer to 1 decimal place, so that'll be 254 point. Now we just want to have 1 decimal place, so 1 number after the decimal point. Now it's 46, that means we're going to round up, so it'll be 254.5 centimeters squared, and that's it. Okay, let's have a look at question number 4. So question number 4 is a non-calculator question, and we've been given a circle with diameter 20 centimeters. So the distance from one side of the circle to the other side of the circle through the center is 20 centimeters. And we've been asked to work out the area of the circle, and we've been asked to use pi as 3.14. So the area of a circle is given by the formula pi r squared, so pi times the radius squared. So that's going to be pi times, now the radius of the circle, if the whole way across is 20 centimeters, the radius would be 10 centimeters. So we're going to do pi times 10 squared. 10 squared is 100, so we're going to have pi times 100. Now it's a non-calculator question. Now sometimes you'd give your answer as 100 pi, but this time we've been told to use pi as 3.14. So we're going to do 3.14 instead of pi times 100, and 3.14 times 100, moving the digits 2 columns to the left, would give us an answer of 314 centimeters squared. So the answer is 314 centimeters squared. Okay, let's have a look at question number 5. So question number 5, this time we've got a circle with a diameter of 9.2 centimeters. We've been asked to work out the area of the circle. So the whole way across the circle is 9.2. So the area is equal to pi r squared. So that's pi times the radius. So halfway across the circle. So it's 9.2, so we're going to need to divide that by 2, half it, to find halfway across the circle. So 9.2 divided by 2 is equal to 4.6. So that means that the radius is 4.6 centimeters halfway across the circle. So the formula for the area of the circle is area equals pi r squared. So it's going to be pi times 4.6 squared. So we're going to type that in on our calculator. It's a calculator question. Pi times 4.6 squared equals 66.47610005 and so on centimeters squared. Now in this question we haven't been asked to give our answer to so many decimal places, like 1 or 2, but let's just round it. I'm going to give this answer to 2 decimal places, so I'm going to give an answer of 66.4, and then we've got 76 now, so that means I'm going to round up to 66.48 centimeters squared, and that's it. So there the circle is 66.48 centimeters squared. Okay, question number 6. So question number 6 reads, a circular fish pond has a radius of 2.5 meters. So we've got a circle and the radius halfway across it is 2.5 meters. We've been asked to find the area of the fish pond and to include our units. So the area of a circle is given by the formula pi r squared. So it's going to be pi times the radius, which is 2.5 squared. So on our calculator we'll do pi times 2.5 squared, and that gives us an answer of 19.63495 and so on. Now this time it's in meters, so meters squared. And let's round our answer to 2 decimal places. So we've got 19.6, and if we have a look, we've got 34, so we're not going to round up, so it's going to be 19.63 meters squared, and that's it. So the area of the fish pond is 19.63 meters squared to 2 decimal places. Okay, let's have a look at question number 7. Okay, question number 7 says, a mobile phone mast has a range of 3 kilometers. So in other words, if you're within 3 kilometers of that mobile phone mast, you might get a signal. And we've been asked to calculate the area of this shaded region, so the area inside the circle, and to give our answer to 2 decimal places. So the area is equal to pi r squared. So to find the area of the circle, we're going to do pi times the radius, which is 3 squared. Now 3 squared is 9. It's a calculator question, so we can just do pi times 3 squared, and that's equal to 9 pi, or because we've been asked to give it the 2 decimal places, 28.27433 and so on kilometers squared, or square kilometers. Now we're going to round this answer to 2 decimal places, so our answer would be 28.2. Now we've got 74, so we're not going to round up, so 28.27 square kilometers, or kilometers squared. So let's write that down, 28.27. So question number 8 says, a circular flower bed has a diameter of 7 meters. So we've got this flower bed and it's got a diameter of 7 meters. I've been asked to work out the area of the flower bed. So we've got the diameter, and the area of a circle is pi r squared. So pi times the radius squared. So if the diameter is 7 meters, we need to half that to get 3.5 meters for the radius. So the radius is 3.5 meters. So we're going to do pi times 3.5 squared. And whenever we do that, we get pi times 3.5 squared is equal to, now we've been asked to give it to 1 decimal place, so let's write it as 38.48451 and so on meters squared, but we're going to round it to 1 decimal place, so the answer would be 38.5 meters squared, because we had 48, we're rounding up, so 38.5 meters squared, and that's our answer, 38.5. Okay, let's have a look at our next question. Question number 9. So question number 9 says, shown below is a circular photo surrounded by a frame. So we've got this circular photo frame, which is shown by, is it lilac or pink or light purple? I'm not entirely sure. Lilac, maybe. And so we've got this circular photo frame, and the photo has a radius of 12 centimeters. So this is the radius of the photo, and the frame has a width of 4 centimeters. And we've been asked to work out the area of the frame. So as you can see here, we've got a circle inside of a larger circle. So if we find the area of this white circle and take it away from the area of the whole big circle, that will tell us what's left, this lilac region, or this shaded region. Okay, so what we're going to do is we're going to consider the whole circle. So we're going to consider that whole circle. Now from here to here is 12 centimeters, and then we've got another 4 centimeters. So the radius of the whole big circle would be 16 centimeters. So for the whole circle, we're going to do pi times 16 squared for the big circle. So pi times 16 squared, and it's a calculator question. So pi times 16 squared equals, and that's equal to 256 pi, or we could write it as a decimal as 804.2477 and so on centimeters squared. So the area of the whole big photo frame is 804.2 so on centimeters squared, or 256 pi centimeters squared. So we could use either one of those. And then if we have a look at the photo in the middle, that smaller circle has got a radius of 12 centimeters. So let's do pi times 12 squared. And when we type pi times 12 squared in on our calculator, we get pi times 12 squared, and that's equal to 144 pi, so 144 pi centimeters squared, or as a decimal number, 452.3893 and so on centimeters squared. Now we want to find this shaded region, so that's the difference between the areas of the circles. So if we take away our 452.38 and so on away from our 804.2477 and so on, that would tell us the area of the shaded region. Alternatively, we could do 256 pi, take away 144 pi, and that would also give us the area as well. So we could use either approach. So let's use both approaches now. So we could use our 804.2477193 and take away the area of the smaller circle, which was 452.3893,421, and we take those away, we get the area of the shaded region, which would be 351.858 and so on centimeters squared. Or if we wanted to give it to two decimal places, 351.8, and then we've got 58, so we would round that up to 86 centimeters squared. Now also, as I was saying, we could use our answers in terms of pi. So we could have done 256 pi, subtract 144 pi. And when we do that, we get an answer of 112 pi. And then we could then change that into a decimal number, and that would be 351.8583 and so on, the same answer. And again, if you rounded it, you get the same thing as 351.86. So that's it. So to get the area of the shaded region, we just worked out the area of the whole big circle, worked out the area of the smaller circle, and took them away to see what's left. Okay, question number 10. Okay, question number 10. We've been given this rectangular garden. So we've got this garden that's rectangular, and it's got a length of 10 meters and a width of 6 meters. And that's what the question says. And we're told that Belle wants to reseed the grass in her garden. So she wants to plant grass seed in that green region. And we're told the garden is 10 meters by 6 meters wide. The vegetable patch, this vegetable patch is 2 meters long and 1.5 meters wide. And there's a circular pond which has a radius of 2 meters. And the remainder of the garden is grass. So we've got this green region here. And we've been asked to, we're told each bag of grass seed is £4.16, covers 10 meters squared, work out the total cost to reseed the garden. So the first thing we want to do in this question is to work out the area of grass. So the area of the whole garden would be 10 times 6. So area of the whole garden would be 10 multiplied by 6, which is equal to 60 meters squared. That's the whole garden. And this rectangle, this flower bed, is 2 times 1.5. The area of this rectangle would be 2 multiplied by 1.5, which is equal to 3 meters squared. So the vegetable patch has got an area of 3 meters squared. So the vegetable patch equals 3 meters squared. The pond, well, this is a circle, so perhaps why this is included in this worksheet. So the pond has got a radius of 2 meters. So the area of the pond is equal to pi times the radius, which is 2 squared. So we're going to do pi times 2 squared, and pi times 2 squared is equal to 12.566 and so on meters squared. We could keep it in terms of pi, which was 4 pi, so you could use either one of those. 4 pi meters squared or 12.56637 and so on meters squared. So we know the area now of the whole garden. We've got the area of the vegetable patch and the area of the pond. So if we take the area of the vegetable patch and the area of the pond away from the area of the whole garden, then that would tell us what's left for the grass. So if we do 60, take away the area of the vegetable patch, which is 3, take away the area of the pond, which was 12.56637 and so on, that will tell us the area of the grass. And that's equal to 44.4336 and so on meters squared. So that's the area of the grass. Now, if we scroll down, and we're told each bag of grass seed costs £4.60 and covers 10 meters squared. So we now need to see how many bags of grass each is going to need. Now I can see straight away it's going to be 5 bags because 1 bag would cover 10 meters squared, 4 bags 40 meters squared. That's the area of the grass is greater than that, so I'm going to need 5 bags. So that's how I would work out we need 5 bags. Alternatively, we could get the area of the grass, which is 44.4336 and so on, and divided by how many square meters each bag covers, which is 10, and that's equal to 4.44 and so on bags. Now we can't actually buy 4.44 bags, so we're going to have to buy 5 bags. And each bag costs £4.60, so we need to do 5 times £4.60 to find the total cost to buy that grass seed. So 5 multiplied by £4.60 is equal to £23. So the total cost for the seed is £23, and that's it. Okay, let's have a look at question number 11. So question number 11 says, a circle has an area of 200 meters squared. Work out the radius of the circle. Now we can do this in 2 different ways. We could do it working backwards, and I'm going to do that approach first of all, or we could do it using an equation, and I'm going to show you that approach as well. So to find the area of the circle, we square the radius and then multiply by pi. So if we want to find the radius, we can work backwards. So we could get our area, 200. We could divide it by pi first of all. So if we do 200 divided by pi, that would give us an answer of 63.66197724 and so on. Now that is the radius squared, because obviously remember we square the radius and then multiply by pi. So if we divide by pi and then square root it, we can then find the radius. So if we square root 63.66197724, that will tell us the radius of the circle. And when we square root that answer, we get an answer of 7.9788 and so on centimeters. We round that would be 7.98. So that means the radius of the circle is 7.98. So that's one approach. Alternatively, you could use the formula. So we know the area of the circle is equal to pi r squared. The area is 200, so we get 200 is equal to pi times the radius squared. Now we just want to find the radius, so we don't want this multiplied by pi and we don't want the squared. So we need to get rid of the multiply by pi first of all, so let's divide by pi and divide by pi. So we're going to do 200 divided by pi, which would be 63.66 and so on, and that's equal to, and we've divided by pi to get rid of the times by pi, so we're just left with r squared. Now we've got r squared equals 63.66 and so on. Now we don't want the r squared, so we want to get rid of the squared. So we're going to need to square root. Now because this is the length of a side, we don't need to worry about negative numbers for the radius of the circle. So we can just square root 63.66 and so on. And then that would give us r. So r equals 7.9788 and so on. So we get the radius that way as well. So you could treat it like an equation and just solve it, and then you could just flip it around and write r equals 7.98. That's it. Okay, let's have a look at our next question. So let's have a look at question number 12. Question number 12 says, a circle has an area of 64 pi centimeters squared. Work out the radius of the circle. So again, we can use either approach here. Now remember, what we do is to find the area of the circle, we square the radius and then multiply by pi. So if we take our 64 pi, we could divide by pi first of all, and that would leave us with 64. And then that's the radius squared, so we could square root 64, and the square root of 64 is 8. So the answer would be 8 centimeters. So that's one approach. Alternatively, you could write area equals pi r squared. The area is 64 pi is equal to pi times the radius squared. We want the radius on its own, so we want to divide by pi and divide by pi to get rid of this pi. So that would leave us, if we had 64 pi and divided by pi, that leaves us with 64, and that equals. And then the right hand side of the equation, we divided by pi to get rid of the pi, so we're just left with r squared. And then finally, we want to find out what r is. It's squared. We don't need to worry about negative numbers, so we can just square root both sides of this equation, and then the square root of 64 is 8, and the square root of r squared, well, we're square rooting to get rid of the squared, so we're just left with r. So r equals 8. So that's another way you can approach that question. That's it. So question number 13. I like question number 13 because we've got the circumference of a circle, so we're using the circumference of the circle and the area of the circle. Circumference is pi times diameter, but area is pi r squared. So we've got our circumference of the circle as 40 centimeters. And to work out the area of the circle, we're going to need to use pi r squared. So we need to find the radius of the circle. So we know the circumference is 40 centimeters. So circumference is equal to pi times diameter. So the circumference of the circle is pi times diameter. So what's happened is we've multiplied the diameter by pi, and we've got 40. So if we divide 40 by pi, we can then find the diameter. Alternatively, you could write it as a formula. You could write 40 equals pi times diameter, and divide by pi, and divide by pi, and then we'll find what the diameter is. So 40 divided by pi is equal to 12.7323, and so on. So that is the diameter of the circle. Now that's the diameter. To find the area of the circle, we need to find the radius, and the diameter is the whole way across, so the radius is halfway across, so we need to divide this by 2. So the radius would be, and if we divide that by 2, so just press and divide by 2 on the calculator, that gives me 6.366197724 centimeters. So that is the radius of the circle. Now we want to find the area of the circle, so the area of the circle is given by the formula pi r squared, pi r squared. So we're going to do pi times the radius, which is our 6.366 and so on squared. So I'm going to press that on my calculator, so I'm going to do pi times answer squared, and that gives me an answer of, there, the circle of 127.3239 and so on centimeters squared. I'm going to round my answer to one decimal place, that'll be 127.3. That's it. Okay, let's have a look at question number 14. So question number 14 says a logo is designed so that it has 4 pink circles within a white square. So we've got this square and we've got these 4 pink circles, and we're told that the square has got a side length of 16 centimeters, and we've been told to find the area of the logo that is white. So we're looking for the area of these white regions, so the area of this logo that's white. So let's start off by finding the area of the square. The square measures 16 centimeters by 16 centimeters. So if we do 16 multiplied by 16, that will give us the area of the square. So 16 multiplied by 16 is 256 centimeters squared. So that's the area of the whole logo. Now if we consider the diameters of the circles, and we actually draw them on here, this diameter and this diameter, now they should be straight, but they're the diameters. And as you can see, those diameters have got a total length of 16 centimeters. That means that each diameter is 8 centimeters. So each diameter of each circle is 8 centimeters. So if we consider the radius, that would be 4 centimeters. So we can find the area of each circle by doing pi r squared. So we could do pi times 4 squared, and that would give us the area of one of the circles. And then there's 4 of them, so we could just do 4 times that area. The area is equal to pi times the radius, which is 4 squared. And 4 squared is 16, so you could write 16 pi, or you could do pi times 4 squared is equal to 50.26548 and so on. I'm actually going to use 16 pi in this question just because it's just a bit neater. So the area of each circle is 16 pi centimeters squared. Now there's 4 circles, so if we take our 16 pi and we times that by 4, and we'll find the total area of those 4 circles. You could take your 50.26548 and so on and times that by 4, and you'll get the same answer. So multiply by 4 would be equal to 64 pi. Alternatively, if you did take your 50.26548 and so on and times it by 4, you would get 201.0619 and so on centimeters squared. And I've actually just done that by changing our 64 pi into a decimal number. So that is the area of the circles. So to find the area of the white regions, this what's left over, if we take the area of the whole square, which is 256, and we take away 64 pi, or 201.0619, so on, I'm actually just going to write 64 pi. And if I do 256 take away 64 pi, or 201, you get an answer of 54.938 centimeters squared to 3 decimal places. And if I just scroll down, the question didn't say to give it so many decimal places, that's fine. So the area of the logo that is white is 54.938 centimeters squared to 3 decimal places. Okay, let's have a look at our next question, question number 15. So question number 15, we've been given a semicircle with a radius of 6 centimeters. And there is a video on Corbettmaths dedicated to finding the area of a semicircle, so feel free to watch that video now if you want a bit more detail in finding the area of a semicircle, but I'm actually just going to do it now. So here we've got a semicircle, and we want to find the area of the semicircle and to give our answer to 1 decimal place. So to find the area of a semicircle, I usually consider the whole circle. So we've got this whole circle, like so. For some reason I always think of a Pokeball whenever I've done that, because I don't know why, it just looks a bit like one to me. Okay, but we've got this circle and we've got a radius of 6 centimeters for this whole circle. So what we're going to do is we're going to find the area of the whole circle and then just half it to find the area of the semicircle. So for the whole circle, we're going to do area equals pi r squared. So that would be pi times 6 squared. And when we do that on our calculator, pi times 6 squared is 36 pi, or 113.0973355 and so on centimeters squared. Now that's the area of the whole circle. We want just the area of the semicircle, so we're going to divide this by 2. So we're going to do 113.097 and so on, and divide that by 2. And when we divide by 2, that gives us an answer for the area of the semicircle, this region, of either 18 pi or 56.548667 and so on centimeters squared. Now we've been asked to give our answer to one decimal place, so that's going to be 56 point, and we've got 54, so it's going to be 56.5 centimeters squared. Okay, let's have a look at our next question. Okay, let's have a look at question number 16. So question number 16 says, a pizza shop sells 2 different sized pizzas. They sell small pizzas with a diameter of 6 inches, or large pizzas with a diameter of 12 inches. And Jackson says that if he orders 2 small pizzas, he's going to receive the same amount of pizza as if he orders 1 large pizza. Explain why Jackson is incorrect. Now I've actually measured these diameters for these 2 small pizzas and this large pizza, and the smaller diameter is half of the larger diameter. And as you can see, it actually looks wrong already, that this larger circle looks like it's got an area that's bigger than these 2 combined. But let's actually work out the areas and show that Jackson is incorrect. So let's find the area of the small pizza. So the small pizza. So to find the amount of pizza he would receive, let's find the area of the top of the pizza. Let's assume that the pizzas have the same thickness. The area of the small pizza would be pi times the radius. Now the radius of the small pizza would be 3 inches, so 3 squared. And pi times 3 squared, well, that's going to be pi times 9, so 9 pi. So that's equal to 9 pi, or 28.274 and so on square inches. So that's the area of the small pizza. Now let's find the area of the large pizza, so the large pizza. So the area would be pi times r squared, so pi times the radius. So if it's got a diameter of 12, the radius would be 6, so the radius is 6. So we're going to do pi times 6 squared. And pi times 6 squared would be, 6 squared is 36, so that'll be 36 pi, or that's equal to 113.097 and so on square inches. So Jackson says that if he orders 2 of these small pizzas, he's going to get the same amount of pizza as a large pizza. So let's actually multiply the area of this pizza by 2 and see what we get. So 2 times 28.274 and so on, and see what we get. So that would be 18 pi, or 56.548 and so on square inches. Now we've been asked to explain why he's incorrect, and so as you can see here, the area of 2 small pizzas would be 56.548 and so on square inches. A large pizza is an area of 113.097 square inches. So I've just written that since 56.548 and so on square inches is smaller than 113.097 square inches, Jackson is incorrect. Another way we could do it is we could actually divide the area of the large pizza by the area of the small pizza and see how many times bigger the area of the large pizza is. And then whenever we do that, we get, well, 36 pi divided by 9 pi would be equal to 4. So that actually tells us the area of the large pizza is 4 times larger than the area of the small pizza. So Jackson would actually need 4 small pizzas to have the same amount of pizza as 1 large pizza. And that's it. Okay, let's have a look at question number 17. Okay, let's have a look at question number 17. So question number 17 says, shown as a circle inside of a square, A, B, C, D, and we've got that circle. And the circle touches the 4 sides of the square. And the area of the circle is 105 centimeters squared. So its area is 105 centimeters squared. Find the area of the square, A, B, C, D. So what we're going to do first of all is, well, we know the area of the circle. Well, let's work backwards. We know to find the area, what we would do is we would do pi times r squared. So we would square the radius and multiply by pi, and that's given us the area of the circle. So if we work backwards and divide by pi and then square root, we can find the radius of the circle. So the center of the circle across to the edge of the circle, and that will be halfway across the square, and that's going to be quite important. So let's take our 105 and divide it by pi, and that would be equal to 33.4225 and so on. So we've divided by pi. Now to work backwards, we would then square root. So we're going to work out the square root of 33.4225 and so on, and then that would tell us the size of the radius. So whenever we square root, that will give us an answer of 5.78122885. So that is the radius of the circle. So the radius of the circle is 5.781 and so on. And it's quite important we don't round this yet, because we're going to then double it and do more things with it. So What I've done there is we were told the area of the circle. So the area of the circle is pi r squared. So we square the radius and then times by pi. So I've worked backwards. I've divided by pi and then square rooted. And that has given us the radius of the circle. Remember, you could make an equation. So 105 equals pi r squared. And you could divide both sides of the equation by pi and then square root and get what r is. And that would give you the radius of the circle. Okay, so we've got the radius of the circle. Now, if you look at the diagram, the center of the circle is also the center of the square. So that means that if we find the diameter of the circle, that would be the width of the square. So we need to multiply this by 2, so the diameter is equal to 2 times 5.78 and so on. So I'm just going to do answer multiplied by 2 on my calculator. That gives me the diameter is equal to 11.5624 and so on. So the diameter of the circle is the same as the width of the square, so that would be 11.5624 and so on centimeters, and that would be the same as the width as well. Now we want to find the area of the square, so what we're going to do is we're going to multiply the length by the width. So we're going to multiply this 11.5624 and so on by itself, or we could square it. So we're going to do 11.5624 and so on times 11.5624 and so on and see what we get. So answer times answer equals 133.6901,522 and so on centimeters squared. So let's round our answer now that we're finished. So our answer would be 133.69 centimeters squared to 2 decimal places. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 18. And the question number 18 is a calculator question. And we're told that Oliver's cutting discs from a sheet of metal. So he's got a sheet of metal and he's cutting out discs from that sheet of metal. And each circular disc has got a diameter of 25 centimeters. So it's got a width from one side to the other side through the center of 25 centimeters. And the sheet of metal measures 2 meters by 1 meter. And the diagram shows the sheet of metal after Oliver has removed 8 discs from the sheet of metal. Okay, so let's have a look at it. So here we've got our sheet of metal and he's removed 1, 2, 3, 4, 5, 6, 7, 8 circular discs from that sheet of metal. And the question A says, calculate the area of each circular disc. So we need to find the area of this circle. So the area of the circle is given by the formula pi r squared. So it's going to be pi times the radius. So that's halfway across the circle. If the whole way across the circle is 25, if we half that, we get 12.5. So it's going to be pi times 12.5 squared. And whenever we do pi times 12.5 squared on our calculator, that gives us an answer of 490.8738 and so on centimeters squared. So the answer would be 490.874 to 3 decimal places. Okay, Oliver removes as many circular discs as possible. Work out the area of metal left over. So let's look at our diagram. He's going to remove as many circles as he can. So if we look at this diagram, each circle has got a diameter, a width here, of 25 centimeters. And he's going to remove as many as possible. Now the sheet of metal has got a length of 2 meters, which is 200 centimeters. So if we want to find out how many circles he can remove in each of these rows, because as you can see there's 4 rows, there's the row on the top, the next row, and then the bottom row. To find out how many circles he can remove in each row, what we need to do is find out how many 25s go into 200 centimeters. So 200 divided by 25 is equal to 8. So that means that in each row there's 8 circles, and I'm going to try to sketch them here. Now this won't be the best sketch, but there's going to be 1, 2, 3, 4, 5, 6, 7, 8. So in each row there'll be 8 circles because 8 25s is 200 centimeters. 1, 2, 3, 4 rows. So there's 4 rows of 8. So if we do 4 rows of 8, that's going to be 4 times 8 is equal to 32 circles. So Oliver removes 32 circles in total from his sheet of metal. Now we want to work out the area of metal left, so that's all these leftover bits. So what we're going to do is we're going to work out the area of 32 circles, and then we're going to take that away from the area of the whole sheet of metal. So let's work out the area of the whole sheet of metal to begin with. The whole sheet of metal is 200 centimeters multiplied by 100 centimeters. So 200 times 100 is 20,000 centimeters squared. So the area of the whole rectangle is 20,000 centimeters squared. Now there's 32 circles and the area of each circle is equal to, now we've got 490.874. I'm actually going to use this unrounded answer, so I'm going to actually use my 490.8738 and so on, just because I'm going to be multiplying it by 32. I don't want to make my error bigger than what it should be, so I'm going to do 32 multiplied by 490.8738 and so on. And I've still got it on my calculator display, so I can multiply that by 32 and that gives me an answer of 5,000 pi, or 15,707.96327 centimeters squared. So that's the area of circles that have been removed from the sheet of metal. So if we do 20,000 take away 15,707.96327, then that would tell us what area of metal is left over. So 20,000 take away that would give us an answer of 4,292.0367 and so on. Now I'm just going to run this to the nearest centimeters. That'll be 4,292 centimeters squared. Okay, let's have a look at our next question. So let's have a look at question number 19. And question number 19 is our penultimate question. And we've got circle A, which has got a radius of 12 centimeters, and we've got a bigger circle, circle B, and we don't know the radius of that circle. And we're told circle A has got a radius of 12 centimeters. Yep, we know that. The area of circle B is 4 times larger than the area of circle A. So this circle has got an area which is 4 times larger than the area of this circle. And we've been asked to find the ratio of the radius of circle A to the radius of circle B. So we need to find this radius. Now to find this radius, what we're going to have to do is we're going to use this bit of information because the area of circle B is 4 times larger than the area of circle A. So we're going to need to find the area of circle A to begin with. So area is equal to pi r squared, so pi times the radius squared. The radius is 12, so we're going to do pi times 12 squared. And when we do that, we get an answer of 144 pi. So 144 pi centimeters squared. So we've got the area of 144 pi centimeters squared. I could write 452.38 and so on. But in this question, we're dealing with ratios, and I'm hoping that these might be quite nice numbers. So let's have a look and see what happens whenever we're dealing in terms of pi here. So we've got the area of circle A. And the area of circle B is 4 times larger, so the area of this circle is 4 times bigger than the area of that circle. So the area would be equal to 4 times this area, 144 pi. So we need to times 144 pi by 4. And that gives us an area is equal to 576 pi. So that's the area of this circle. Now, we want to find the radius of the circle, but we know its area. And to find the area of a circle, we square the radius and then multiply by pi. So if we take this area and work backwards, we could divide by pi and then square roots. So if we take our 576 pi and divide it by pi, that will tell us whatever we get when we square the radius, which would be equal to 576. Now we just need to square root 576, and that would tell us the radius. So the square root of 576 is equal to 24. So the radius of this circle is equal to 24 centimeters. And we've been asked to find the ratio of the radius of circle A, which is 12, to the radius of circle B, which is 24. So a ratio would be 12 to 24. Now we can cancel this down. We can divide both of these by 12, so we get 1 to 2. So the ratio of the radius of circle A to the radius of circle B would be 1 to 2. And that's it. Okay, let's have a look at our last question, question number 20. So question number 20 says, Kirsty is designing a logo for her company. So this is her logo. It looks like a rectangle with like a tornado or something coming out of it, twister, I don't know. Okay, so we've got this logo for her company, which has this lilac or shaded region and the white region as well. Don't scribble on. And she's drawn a rectangle A, B, C, D, where AD is equal to 8 centimeters. Yep, we know that. And CD is equal to 12 centimeters. Yep, we've got that. And we've got AD, so this is the diameter of a semicircle. Yeah, you can see the semicircle here. This is a semicircle. And we're told that DE is the arc of a circle, centre A. So if you have this circle and you've got the centre A, then this is the arc. So, and if you notice, this is a right angle, so this is going to be a quarter circle. So AED, that is a quarter circle. And we've been asked in this question to find the percentage of the logo that is shaded. So we've got this whole logo. Let's find the area of the whole logo to begin with. So that's going to be 8 times 12. So 8 times 12 will give us the area of the whole rectangle. And 8 times 12 is 96 centimeters squared. So that's the whole area. And whenever we're working out the percentage, that's going to be quite useful. Okay, now we want to find this shaded region here. Now, what we know is we've got a quarter circle. So if we find the area of the quarter circle and then take away the area of the semicircle, that would tell us the area that is shaded here. So let's find the area of the quarter circle to begin with. So if we had a whole circle, if you looked at ADE, that is a quarter circle. So forgetting the semicircle has been cut out, if we wanted to find the area of this whole quarter circle here, this part, what we're going to do is we're going to find the area of the whole circle, and then what we're going to do is divide it by 4, this whole circle that I've drawn, and we're going to divide it by 4, and that would tell us the area of ADE, this quarter circle. So let's do that and see what we get. So we've got this whole circle. It's got a radius of 8 centimeters. Don't look at the diagram, it's a bit misleading, but if I had done a really good circle, that would be 8 centimeters would be the radius of it. So we're going to do pi times 8 squared. And whenever we do pi times 8 squared, that would be 64 pi, or if you wanted to work in decimals, that would be equal to 201.0619 and so on. I'm going to use 64 pi here. So that would be the area of this whole circle. Now I just want the area of this quarter circle, this ADE quarter circle here. So I'm going to divide this by 4, and if I do 64 pi divided by 4, that's equal to 16 pi centimeters squared. So that means that the area of ADE, this quarter circle, would be 16 pi centimeters squared, or 50.265 and so on centimeters squared. So that's the area of ADE. But if you look at that quarter circle, there's a semicircle that's been cut out of it. So if we look at this semicircle, AD is the diameter of the semicircle, so let's turn it into a circle. So this is our circle now, and we want to find the area of this semicircle. So to find the area of the semicircle, we find the area of the whole circle and then half it. Now the center of the circle is going to be here. The whole length AD was equal to 8 centimeters. That means that A to the midpoint, the radius of this whole circle, would be 4 centimeters. So we're going to do pi times 4 squared to get the area of the whole circle here, and then half it, and that will tell us this area, this white area here. So we're going to do pi times 4 squared. Now that would be equal to pi times 16, so that'd be 16 pi, or if you wanted to work in decimals, that would be equal to 50.265 and so on. 50.265 and so on centimeters squared. So that's the area of this whole circle, but we want the semicircle, so we're going to divide that by 2. So we're going to do 16 pi divided by 2 is equal to 8 pi. So the area of this semicircle is 8 pi centimeters squared, or as a decimal number, that'd be equal to 25.1327 and so on centimeters squared. So if we go back to our logo, we want to find the area of this shaded region. And to do that, what we're doing is we're considering the quarter circle, and then we're taking away the area of the semicircle to see what area would be left for this purple region. So the area of the quarter circle was 16 pi, or 50.265 and so on centimeters squared. So that would be the area of the whole quarter circle. And the area of the semicircle is 8 pi. So we've got 16 pi, take away 8 pi. And that means that we'll be left with 8 pi centimeters squared. Or alternatively, it could be 50.265 and so on, take away 25.13 and so on, and we'll be left with 25.1327 and so on centimeters squared. So we now know that this shaded region has got an area of 8 pi centimeters squared, or 25.1327 centimeters squared. Now we want to find the percentage of the logo that's shaded. So we know that 8 pi is shaded, and the whole area is 96 centimeters squared. So we just need to convert this into a percentage. So we're going to divide 8 pi by 96, and then that gives us a 12 pi, or that's equal to 0.261799 and so on. Now we want this as a percentage, so the answer would be 26.1799%. Or 2 decimal places, 26.18%. And that's it. So these have been the video solutions to the area of a circle practice questions. I really hope you found this video useful. If you need any extra help on the area of a circle, feel free to watch videos 40 or 59 on Corbettmaths. Alternatively, you could scan that QR code. I hope you found the video useful. If you have, please like it, please subscribe to my YouTube channel, and thanks so much. Cheers. Bye.